Hi boys and girls, this is lesson 5.1, all about fraction decomposition. Make sure you get that written in your notebook along with today's date. When you're ready, come on back. Okay, so take a look at the pictures that I've included for you there. I want you to understand that the red circle is the whole. For today's whole lesson, the red circle is going to be what we're thinking about as the whole, okay? So the question is, how could you use the yellow fraction circle pieces to show 3/4? What equation can you write to show 3/4 as the sum of the yellow fraction circle pieces? Give that some thought, pause the video, write what you're thinking, and when you're done with that, come on back. So here's some questions. So if you got a little stuck, no worries. Here's some questions to get you moving forward on that last question I was asking you. So how many yellows did you use to show 3/4? So the next question, what fraction of the whole is one of the yellow pieces? And how many fourths did you use? And then take a look at the equation you wrote. Do you need to adjust it based on answering the questions that I'm looking for you to answer? So make sure you have these questions answered and you've given another try to that equation. And when you have that done, come back again. All right, so how many yellows would you use to show 3/4? Well, 3, right? That's what we see in the picture to the left. It would take 3 yellows to show 3/4. Then what fraction of the whole, remember the whole is the red circle, is 1 yellow? Well, it's 1 out of the 4, so 1/4. And how many fourths did you use in order to show 3/4? You used 3/4. Interesting, right? 3/4 can be written in words to show that there's 3 pieces, or it can be written as a fraction, 3/4, 3/4. And then for the equation, you hopefully wrote 3/4 equals 1/4 plus 1/4 plus 1/4. Of course, that could be turned around so that it's 1/4 plus 1/4 plus 1/4 equals 3/4. As long as you have both sides of the equals side written, it wouldn't matter in which order that goes. So I want to talk about those 1/4. So that's a unit fraction. So any fraction with a numerator of 1 would be considered a unit fraction. That's really going to be important that you understand that. So I've written a little bit more about it on the bottom here. Make sure that you get this. If whatever of this you need to write in your notes, do so. So it says to you, so 1/4 would be the unit fraction. Any fraction, a over b, remember that's the unknown, it's a variable, I can put any letter there, can be written as the sum meaning I've added things together to equal it, of unit fractions with the denominator b. So for example, 3/4 can be written as 1/4 plus 1/4 plus 1/4. And that's what this right here is supposed to be showing you. This equals this, which equals this. All right? So take some notes for yourself. When you think you're set, come on back. Okay, so let's write some equations for these fractions as the sum of unit fractions. I did the first one for you so you'd be sure to understand what I'm looking for. So for 2/10, we can look at that, we can decompose that to show that 2/10 is equal to 1/10 plus 1/10. You go ahead and do that for the next 3 fractions. Look carefully at the third one down, so 4/3. That's an improper fraction, right? It still works. You can still do it the same way. Just watch the amount of fractions you're adding together. So when you do that, That's called decomposing the fractions, or breaking them down into smaller parts. That's what that big word means, right? All right, so when you get that done, come on back. And here we show. So 5/8, we already did the 2/10, so 5/8 equals 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. That makes sense. And then for 4/3, you can see that I had to have 4 of those because it's 4/3, right? So 4 1/3 would equal 4/3. And the same is done here. Again, remember that's decomposing the fractions or breaking them down into smaller parts. That's the concept I want to make sure that you're getting. Oops. So the red circle is still the whole. Now I want to talk about fifths. So I put some pictures there to help you. How many dark greens did we need to show 4/5? What fraction of the whole is 1 dark green? Remember, the whole is the red circle. And what equation would show 4/5 as the sum of unit fractions? So do that work, and when you're ready, come back. Okay, so I hope that you understood that 4 dark greens, and you can see it represented here, and then this is what it would look like if I was putting it into the actual circle, right? 1, 2, 3, 4. So 4 dark greens. What fraction of the whole is 1 dark green? Well, that would be the unit fraction of 1/5, because it would take 5 if I was making the whole, right? So the denominator is 5, because that's how many pieces it would take to make the red circle. So one of them would be 1 out of the 5, or 1/5. And then the equation again, so this time I wrote it with the equals 4/5 on the right. It could go either way. This can go here, or it could go over here, 4/5 equals these. Either way is perfectly fine. Just make sure you have that written for yourself. And then here's a question. So can you think of another way that we could decompose 4/5 into the sum of 2 or more fractions that have 5 as the denominator? So is there another way, or do I have to do it 1/5 plus 1/5 plus 1/5 plus 1/5? Is there another way of doing that to still get to 4/5? Think about that. Give it a try. When you're ready, come back. So here's a way. Couldn't I do 1/5 plus 1/5 plus 2/5 equals 4/5? I certainly could. Or how about 3/5 plus 1/5 equals 4/5? Or 2/5 plus 2/5 equals 4/5? 4/5 plus 0/5 equals 4/5. Do you see that I could do any of these as my decomposition of 4/5? It doesn't have to be the unit fractions, though it could be. So these would not be considered unit fractions because they don't have a 1 on the top. That's still okay, as long as I do understand this is my unit fraction, right? All right, so here, now you give it a try. Let's try to decompose a couple more fractions. Try 7/12 and try 120 over 100. Try and do it in a couple different ways, each one of those in a couple different ways. When you're done, come back. So I just gave you an example. I could have done, you could have done, 3/12 plus 4/12 equals 7/12. There's a ton of other ways. As long as your numerators equal 7 and you have 12 as your denominators, you have it right, whatever way you chose. Same would be true for the 120 100ths. I did this way, 50 hundredths plus 50 hundredths plus 20 hundredths equals 120 hundredths. But you could have done a lot of other ways, as long as the numerator, when you add them together, equals 120, and you kept the denominator 100. All right, here comes a little challenge. So let's try that same concept now with a mixed number. So the mixed number is 1 and 2/8. 1 and 2/8. So here's what I want you to think about. I want you to decompose it into an equation with the sum of fractions with the same denominators. That's all we've done so far. Do it again and decompose it in more than one way. Give it a try with that mixed number. If you're right now going, oh wow, I don't have any idea, here's a hint for you. You might consider starting by making an equivalent fraction, which in this case could be an improper fraction because I'm using a mixed number. So if that helps you, super, give it a try. Come back when you're ready. So I added a little bit more to that hint in case you were still a little stuck. So for 1 and 2/8, I could say 1 and 2/8 breaks down to 1 plus 2/8, which would then be 8/8, because we know that 1 is 8/8, right? 1 whole is always the top number and the bottom number the same. All right, so 8/8 plus 2/8, that's where we're going here. That's what this is coming from, right? That's this, which I could write like this. It ends up giving me this. So the improper fraction, which is an equivalent fraction for 1 and 2/8, would be 10/8. Okay, so now that you have that, if you were stuck, decompose that in a couple different ways. When you think you have it, if you needed that extra time, try it again. If not, if you already have it, go ahead and go to the next slide. All right, so here's some examples. You could have done 8/8 plus 2/8 equals 1 and 2/8, or 5/8 plus 5/8 equals 10/8. 2/8 plus 2/8 plus 2/8 plus 2/8 plus 2/8 equals 1 and 2/8, or 10/8. I'm okay to write 1 and 2/8 or 10/8. I'm good either way. I'm okay if this is on the left side or the right side. I just have to have an equation, an equals sign with the two sides being equal. All right, I hope you had some fun with that. Let's try one more. 2 and 2/4. No hints coming from me this time. Figure that out. You can do it. When you're ready, come back. So here's an example. Yours might not match mine. That's perfectly fine. As long as yours equals this, when you're done, you're good. So I went an easy way. I'm saying 1 plus 4/4, which means 1 plus 1, right? 4/4 is equal to 1. 1 plus 1 is 2, plus 1/4 plus 1/4. So 2 plus 2/4 gives me 2 and 2/4. So that's the way I did it. You might have done it quite differently. That's okay. All right, you're going to work on page 155 in your math journal. When you have that page done, come on back to check out your answers. When you come to group, I'll be looking over that page with you and asking you a couple challenge questions, so be ready for those. And there are the answers for page 155. Notice that in that first direction it was asking you for unit fractions, so that's the way you had to do that one, because that's what it asked you for. And then notice that the other ones are sample answers. You might not have had yours match that. That's okay. All right, we'll take a look at what you did. We'll have someone else in the group check you over, make sure you're good. But that is one way you could have done those problems. All right, see you in group.